Oh, the tropical paradise that is Bubbline. Nice, white, sandy beaches, calm sunsets, and a slight fizz over the ocean. Hello, it's me, Loxton, and no, I'm not on vacation. I'm here trying to figure out the oddities of the Mario universe. Today, I'm going to find out if it is possible to swim in a carbonated ocean. And what in Miyamoto's name is a carbonated ocean? In this world of Super Mario Odyssey, we've seen many things that really get my noggin going, and it actually wasn't until I heard the gentle fizz of the water while exploring that I realized that they did mean that the entire ocean here is carbonated, not just the water in the big glass bottle. In the travel guide, we see that it states that the ocean here is simply carbonated. But have you ever tried just straight carbonated water? Gross. But when the carbonated water of the ocean gets put into the large glass vase, it gains its delicious sparkle water title, meaning there is probably some flavor enhancers and filters involved in the process of the water being sucked up into these things and then being shot into the glass. But is a carbonated ocean even possible? Perhaps at least this little tiny part of the ocean. Is that even possible? I mean, I'm talking about the real world here. Clearly it's possible in the Mushroom Kingdom with magic, but, you know. And if it is possible, could you even swim in it? I mean, carbonated water is just water that has had CO2 gases dissolved into it. That's what makes it so bubbly. And the Mythbusters did an episode on that very question and found that swimming in bubbling water is plausible. You can stay afloat, but it is rather hard due to the water currents changing the swimmer's location. There are also plenty of YouTube videos of small-scale bubblers dragging corks and other lightweight objects down because of the loss of buoyancy. This is also a real problem in the shipping world. Due to the ocean's salt content, you are actually more buoyant than when you're in freshwater. I'm guessing that the water here in this part of Mario's ocean is not salted, or at least this small location is somehow freshwater. I mean, salt water's nasty, so carbonated salt water. I'm just saying, you know, this water is known for being delicious, yeah? There is no way to filter out that much gross in such a short amount of time. So perhaps all this carbonation in the water pushes the salt parts of the ocean away from this lagoon. I don't know. But anyway, the reason bubbling water is bad for the shipping world is because of the way boats work. They displace enough water and their weight is distributed enough that they can remain buoyant over water. But if suddenly there were loads of bubbles coming up, that's a load of air against the bottom of the boat. Boats don't float on air, they are not planes. Most of the time, anyway. So put enough bubbles under a boat and yes, it can sink. But boats tend to be big and heavy. And while those same words fit the description of Mario, it's definitely not on the same scale. And this sea may not be that bubbly and carbonated. Well, as always, we are going to have to gather our research first. What is carbonated water exactly? Carbonated water, also known as club soda, is water or H2O that has the gas CO2 or carbon dioxide dissolved into the liquid while under pressure. Invented in 1772 by a Joseph Priestley accidentally, the bubbly drink was loved for the particular effect the bubbles would cause on one's tongue. But that's not fully true. Another origin of carbonation in beverages comes from the process of making alcohol. A common side effect of the fermentation process is carbonation. But even before man's artificial bubble water, Mother Nature has created seltzer water for millennia. Fun fact, it's called seltzer water because it was originally found nearby the German town of Seltzers. And actually, all water on Earth is naturally slightly carbonated due to CO2 being present in the air. It mingles with the water on the surface, but only becomes bubbly when the CO2 is fully saturated or oversaturated to the point where the CO2 is trying to escape from the water, hence the bubbles. One large source of natural carbonated water is Soda Springs, Idaho. This small town is home to a multitude of naturally carbonated springs. Geothermal activity hundreds of feet below the ground heats water and mixes in carbon dioxide gas, creating the natural carbonated water. In fact, this location is home to the only captive geyser ever. During a drilling operation on November 30th, 1937, the drill went down 315 feet and unleashed the geyser. And now the geyser is kept and controlled by a timer. It erupts every hour on the hour, and it reaches heights of 100 feet year-round. So now we know that carbonated water can be formed naturally. So the next part of our research is about buoyancy. I've said that word a few times, let's dig into its real meaning now. Buoyancy is the measurement of upward force imparted onto an object by by the liquid it is in this case, Mario in the water. Much like normal humans in water, we have a large buoyant force that is able to almost keep us afloat. This varies based on your body mass and such. I personally float, but there are other people that I know that just sink like rocks. So we need to know if Mario's buoyancy is affected by the carbonated sea. We see that he can and does sink, but he is also able to stay afloat with some light kicking. Every liquid has a buoyant force that they can exert on objects. Some can hold much heavier things, like a whole metal coin floating on mercury, or oil floating on top of water. So the question is, what kind of difference in buoyancy does carbonated water have compared to normal water? Well, we can figure this out by weighing 1 liter of water and 1 liter of carbonated water. And based on my research, we can see that the carbonated water is slightly heavier. Even though it has air bubbles in it, the CO2 molecules are actually slightly more hefty. This is of course assuming you are measuring by true volume and not ignoring the volume of those little bubbles. Much like salt water, carbonated water is more dense than plain water, which is due just because there's plain more stuff in the carbonated water. There's carbonation. So if carbonated water is actually denser, then why would it be hard to swim or float in? Well, it's all those little bubbles that cause the problems. You see, the reason it's hard to swim in bubbling water is because the water mixed with the air bubbles has a lower density than just the water. So your buoyant force is much lower, so you sink faster. So you need to exert more energy kicking up. But hang on, that might be confusing. So carbonated water is more dense than just water, but all of the carbonated air bubbles makes it less dense? That is definitely a bit confusing, so let's explain with an example. Say you have a can of soda. You know how if you shake that can before opening, the can will explode? Why is that? Well, long story short, carbonation doesn't like being in water. It looks for every chance it can get to escape. That's why if you leave soda out for a while, it goes flat. But the water molecules don't want to let the carbonation go, so they hold on to it, trap it, albeit very weakly. Inside of your unopened soda can, there are actually no air bubbles inside the liquid at all, besides just more carbonation. It's all just liquid. This means there is nowhere for all of that trapped gas to go. It's blocked. But when you open your can, you introduce the oxygen and nitrogen in the air to the soda inside. Finally, a place for the carbonation to go. That's why when you first open your can, there's that iconic. But then why does shaking the can beforehand cause it to explode even more? Well, explained very basically, the water and CO2's link is very weak, meaning when you suddenly applied a lot of motion, it weakens them further. You shook them apart. More CO2 can escape all at once when you open the can. That's also why when you first pour soda into a cup, it's especially fizzy, but it eventually evens out. All that motion from you pouring it makes it easier for CO2 to escape. In Mario's case, that's why normally the water here looks just a bit fizzy, but when you jump into it and start swimming around, it suddenly gets way fizzier. So when the carbonated sea is just being a carbonated sea, the water is much denser than normal water. But when you disturb it, you create a bunch of air bubbles which overall reduces the density in that area. And depending on the ratio of air to water, it could basically just be water, no problem at all. Or on the flip side, it's much like trying to swim up the rain. And I don't know if you've ever tried that. I have. And I can tell you from personal experience that it doesn't work. In fact, recent studies have shown that it's possible even for entire tankers to sink in mere moments due to the bubbling methane fields underneath the Bermuda Triangle, explaining the reason why so many ships go missing there. You would think that the bubbles going up would in fact help you stay afloat because of the currents they create, all that upwards force. But when bubbling water creates a current upwards, it then hits the water's surface, and when it hits the water's surface, that current gets reflected straight back down, creating a sort of suction that helps to pull whatever was on the surface down into the farty depths. That was a methane joke, I'm sorry. This is the main reason I'm not sure Mario would be able to swim in a carbonated sea in a real-world scenario. But, unlike bubbling water, this carbonated sea is much more calm and only bubbles softly. If this ocean were in a much colder environment, I could see it even not having bubbles at all unless it gets especially agitated, as warmer water holds the carbon dioxide even weaker than cold water. But yeah, the carbonated sea isn't that carbonated. If this ocean were oversaturated with carbon dioxide to the point of fully bubbling like a full-on boil, then yes, I could see Mario not being able to float. But the gentle fizz we can observe from the sea is much less volatile. If anything, Mario's butt would just get a little tingly from all the bubbles giving it a gentle caress. Yahoo! In fact, he may be able to float much better due to all the air bubbles increasing his surface area by being attached to him, the same way that air bubbles in your soda drink attach to the sides of the cup walls. This would increase Mario's surface area without adding much mass. But then, you know what the next question that arises is? What about all those fish that live in the water? Is it even possible for them to exist with all this carbon dioxide in the water? Wouldn't they suffocate? What if that's why the octopus enemies evolved not to swim in the water, but use mustache magic to levitate and have its own bubble of filtered water around it? Huh. Neato. Anyway, we all know that fish need oxygen that they get from their gills by moving water across them. But what would happen if the water was carbonated? Especially carbonated. Well, thankfully, CO2 does not compete for a spot in your hemoglobin or blood like oxygen does, so the fish wouldn't suffocate, per se. So imagine if the air was carbonated. But wait, it already is. Imagine if the air was even more carbonated. There isn't any less oxygen, there's just more CO2. All this means is you would have to breathe a little bit harder and a little bit faster to get the same oxygen. But you wouldn't die from a lack of oxygen. The same goes for the fish. But because CO2 is acidic, it is bad for most organisms. And unlike humans, fish can't just breathe out all the CO2 as gas. Fish have a rather complex system to dispel CO2 because they do naturally intake CO2, just not in high amounts. The problem is when their natural processes are outpaced and CO2 builds up in their gills and blood to high amounts, this would cause acidosis, or an acidity of the blood, which could possibly lead to organ failure. Put simply, CO2 wouldn't just kill them right away or anything, but it may affect how they grow and behave due to the CO2 levels affecting them during their vulnerable egg cycle. Fish are pretty hardy when it comes to the oxygen levels in water, but it's the acidic CO2 that they breathe that would ruin their whole week. Sad face. So I guess that's what the tropical paradise of Bubbline is to fish. A place where they either die or evolve beyond. Those cheep must be some rather hardy fish then. That, or they are just too dumb to understand that they should die. So I hope you enjoyed this dive into the world of carbonation. What kingdom should I look into next? Let me know down below, and if you'd like to help this channel stay afloat, there are some support links down in the description. And as always, thank you so much for watching, and never stop using your noggin. Delicious sparkle water title, meaning there is probably some flavor enhancers and filters involved in the process of the water being sucked up into these things and then being shot into the glass. But is a carbonated ocean even possible? Perhaps at least this little tiny part of the ocean. Is that even possible? I mean, I'm talking about the real world here. Clearly it's possible in the Mushroom Kingdom with magic, but you know. And if it is possible, could you even swim in it? I mean, carbonated water is just water that has had CO2 gases dissolved. See, we've seen many things that really get my noggin going, and it actually wasn't until I heard the gentle fizz of the water while exploring that I realized that they did mean that the entire ocean here is carbonated, not just the water in the big glass bottle. In the travel guide, we see that it states that the ocean here is simply carbonated. But have you ever tried just straight carbonated water? Gross. But when the carbonated water of the ocean gets put into the large glass vase, it gains its the tropical paradise that is Delphina, I mean Bubbline. Nice, white, sandy beaches, calm sunsets, and a slight fizz over the ocean. Hello, it's me, Loxton, and no, I'm not on vacation. I'm here trying to figure out the oddities of the Mario universe. Today, I'm going to find out if it is possible to swim in a carbonated ocean, and what in Miyamoto's name is a carbonated ocean? In this world of Super Mario Odyssey, delved into it. That's what makes it so bubbly. And the Mythbusters did an episode on that very question and found that swimming in bubbling water is plausible. You can stay afloat, but it is rather hard due to the water currents changing the swimmer's location. There are also plenty of YouTube videos of small-scale bubblers dragging corks and other lightweight objects down because of the loss of buoyancy. This is also a real problem in the shipping world. Due to the ocean's salt content, you are actually more buoyant than when you're in fresh water. I'm guessing that the water here in this part of Mario's ocean is not salted, or at least this small location is somehow fresh water. I mean, salt water's nasty, so carbonated salt water. I'm just saying, this water is known for being delicious, yeah? There is no way to filter out that much gross in such a short amount of time. So perhaps all this carbonation in the water pushes the salt parts of the ocean away from this lagoon. I don't know. But anyway, the reason bubbling water is bad for the shipping world is because of the way